next section we are going to talk about is we're going to apply different properties of similar triangles. The first property is called the triangle proportionality theorem. If a line parallel to the side of a triangle intersects the other two sides, then it divides those sides proportionally. For example, if you have a triangle, and we'll call this triangle ABC. If you have a side, if you have a line parallel to this side of a triangle, right here, so if you know these two are parallel, then we know that that line will divide the sides proportionally. So if we call this point E and this point F, then what we can say about this triangle is we can say that AE over EB will equal AF over FC. The next theorem we have is called the converse of the triangle proportionality theorem. So if a line divides two sides of a triangle proportionally, then it is parallel to the third sides. So in this case, if we draw another triangle, if we say that this triangle again is ABC and EF, we'll call this line EF. So if we know, in this case, we knew that EF was parallel to BC. So in this case, if we know that AE over EB is equal to AF over FC, then we can say that EF is going to be parallel to BC. So one just says if the lines are parallel, then this over this is going to equal this over this. And the other one says if we know this over this equals this over this, then we know the lines are parallel. Our next theorem is called the two transversal proportionality theorem. And this says if three or more parallel lines intersect two transversals, then they divide the transversals proportionally. For example, if you have a line here and you have a line here, so those are going to be my transversals. If three or more parallel lines intersect them, so I'm going to draw my three parallel lines. So we're going to say that all three of these lines are parallel. So if we know those lines are parallel, then we can divide these sections proportionally. So if I call it A, B, C, D, and EF, if these lines are parallel, then we know that AC over CE is going to equal BD over DF. So it's very similar to the triangle proportionality theorem, except it's not in a triangle. Our last example of our theorems is called the triangle angle bisector theorem. Now the triangle angle bisector theorem says an angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So for example, if you have a triangle, so I'm going to say this is triangle ABC, an angle bisector of a triangle, so I'm going to bisect this angle up here, which makes those two equal, and then I'm going to call this point D. What it does is it divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So for example, in this case, we would say AD, this segment here, over this segment here, DC, is going to be proportional to AB over CB. All right, here's our first example. In our first example, we're going to do the triangle proportionality theorem. We're actually going to use that theorem in all four of these examples. So we are going to find CY. So I'm going to call CY X. And the first thing I'm going to do is say, since we know these are parallel, then we know that 9 over 4 is going to equal 10 over X. So once we do this, we're then going to cross multiply. So we'd say 40 equals 9X. Divide by 9. And when we take 40 and divide by 9, we get X equal to 4.4 repeating. And once we know what X is, we then have to figure out what CY is. because CY is just X, we know that CY will be 4.4 repeating. In our next example, we're trying to find PN, so I'm going to call PN X. Again, we know our lines are parallel, so we can set up equal proportions. Over here, this little number got cut off, so that would be a 2 over there. So MQ is 2. So the first thing we're going to do is we're going to set up our proportions. So I'm going to say X over 3 equals 5 over 2. Once we do this, we then cross multiply. 15 equals 2x. Divide by 2. X will be 7.5, which then means Pn will also be 7.5. On our next example, we need to find US. So I'm going to take it and I'm going to call US X. And again, I'm going to use my triangle proportionality theorem to set up some proportions. So we're going to say 14 over X equals 10 over 4. So when we do this, the first thing we do is we go 10x equals 56 when we cross multiply. And I'm going to divide by the 10. X will be 5.6. Once we get X, X and US are the same, so US will also be 5.6. In our last example, we are again trying to find EG. Because these two sides are parallel, we can use our triangle proportionality theorem. So I'm going to say 5 over 7.5 equals 6 over X. When we cross multiply, the first thing we do is 7.5 times 6, which is 45. That equals 5x. Divide by 5. X will be 9. Once you have X, you also know that EG will also be 9. Okay, if we then flip our page, we are now going to just verify that the lines are parallel. If these two lines are parallel, that means these proportions have to be equal. So we have to know that 10 over 15 equals 8 over 12. A couple ways of doing this. One way is just to cross multiply and say 15 times 8 is 120, and that also has to equal that, which is 120. So we then verified that these proportions are going to be equal. In this next case, we're doing the same thing. We have our proportions. We have to verify that these lines are parallel. If our proportions are the same, then we know that the lines are parallel. So I would say 42 over 21 must equal 30 over 15. Another way to check to make sure that these proportions are equal is just take each portion and reduce it and make sure they're equal. If you reduce this, you get 2 over 1. If you reduce this, you get 2 over 1, and you can then say the proportions are equal. It's just another way of saying kind of the same thing. All right, in our next example, it says an artist used perspective to draw the guidelines to help her sketch a row of parallel trees. She then checked the drawing by measuring the distance of the trees. We need to find LN. All right, the first thing we need to do is we need to find the distance from L to N. So if you take a look at my picture, I'm going to put the length of KL. KL here is 2.6. And I'm going to put that over the distance of LN, which we don't know, and we'll call that X. We then correspond that kind of piece to the other side. KL, the 2.6 KL corresponds to AB, which was 2.4. And the LN corresponds to BD. So if you get these two distances together, from B to D, it will be 3.6. From that point, you then just cross multiply. So we have 2.4x, and that equals 2.6 times 3.6. When you multiply those two, you get 9.36. You then divide by 2.4, and x is going to be 3.9. Because we called all of ln x, we then know that ln will also be 3.9. In the same picture, the artist decided to make a larger sketch of the trees. So AB is now 4.5, BC is 2.6, CD is 4.1, and KL is 4.9. So I'm going to kind of redraw my picture off to the side here. So we have A, B, C, and D. We have K, L, M, and N. And from A to B is 4.5, B to C is 2.6, C to D is 4.1, and K to L is 4.9. We have to find LM. I'm going to call LM X, and we have to find MN, and I'm going to call MN Y. So the first thing I'm going to do is I'm just going to set up some proportions. So I'm going to go 4.9 over X, and then I'm going to match them. 4.9 matches 4.5 over X matches 2.6. When you cross multiply, you get 4.5X equals 2.6 times 4.9 is 12.74. When you divide that, X is going to be 2.83. So LM will equal approximately 2.83. I am then going to set up another proportion, but this time I'm going to go 4.9 over Y, and that's going to equal 4.5 over 4.1. And when you cross multiply that, you have 4.5Y equals 4.9 times 4.1 gets you 20.09. If you divide by 4.5, you then get Y equal to 4.46, which means then MN will also equal 4.46. In our last section, we are going to primarily deal with the triangle angle bisector theorem. And what we're going to do is look at the equal pieces. So on our front page, we had talked about the equal pieces of these triangles. So if you take a look at your first example, what we do is we find the side lengths across from where it's bisected and you pick one. So 5 is going to correspond to 4. And then you go back to your original triangle and you put your other sides. So this is going to 5 matches x plus 3 in terms of what triangle it's a part of. And x plus 3 is going to correspond to x minus 1. Once you have that proportion, you just cross multiply and solve. So in this case, when I multiply those, I get 4x plus 12. That's going to equal 5x minus 5. I'm going to subtract 4x. At the same time, I'm going to add 5 to get my variables on one side, my numbers on the other. So I have 17 equals x. Once I have 17 equals x, I then have to plug it in. When I plug 17 in for NP, we can say that NP will equal 17 minus 1 is 16. And LP, 17 plus 3 is 20. In our next example, we're going to do the same thing. So I have 4.5 over y over 2. That's like a 1/2 y, so I'm going to make that a 0.5 y just to make it simpler. 4.5 matches 8 over y minus 2. From here, we're just going to cross multiply and solve. 0.5y times 8 is 4y. That's going to equal 4.5y minus 9. You have to distribute the 4.5 to both pieces. I'm then going to simplify by subtracting 4.5y. So I have a negative 0.5y equals negative 9. And I'm going to divide by negative 0.5. So y is then going to equal 18. Once I have y equal to 18, I'm then going to plug it in. So AC, 18 minus 2 is 16. And I'm also going to get DC. 18 divided by 2 is 9. So those would be your two solutions for this problem. Our last two examples are very similar. So in this case, I'm going to start with x plus 2. X plus 2 corresponds to 2x plus 1. Come back to your original. You still have the side length of 10, and that corresponds to 14. When you cross multiply, you get 20x plus 10 equal to 14x plus 28. I'm going to subtract 14x and subtract 10 at the same time. to save some time. So then I have 6x equals 18, so x will be 3. Once you get x to be 3, our v will then be 5. Plug it in, 3 plus 2 is 5. And vt will be 3 times 2 is 6, plus 1 will be 7. Then we have our last example. So in this situation, I have x. X corresponds to x. X corresponds to 6. And that's going to equal x plus 3 over 10. When you cross multiply, you get 6x plus 18. That equals 10x. And then I'm going to subtract the 6x. 18 equals 4x. And then I'm going to divide by 4. And x is going to equal 4.5. From there, I can get LP. LP is just x, so LP will be 4.5. And I can get LM. And 4.5 plus 3 is 7.5. And those are your two solutions.